Good morning, my dear students. My name is Anjane Sharma, working as physics lecturer in one of the reputed institution. Today we are going to know numerical part of physics. So very important for all competitive exams. That is based on this differentiation, integration, dot product, cross product, graphical part. So based on all this, definitely you will be given 3-4 questions. No? So first we'll discuss about differentiation. So in this problem, you have given angular displacement. So angular displacement of the body is given as t cube plus t square plus t plus 1. So you want to find angular velocity. You have given angular displacement, you want to find angular velocity. How? By differentiating this function with respect to t, we get angular velocity. 3t square. Differential value of t cube is n into x power n minus 1 na? So that is why 3 into t power 3 minus 1. So 2 into t power 2 minus 1. And differential value of t, 1, and any constant 0. So you get angular velocity omega is equal to 3t square plus 2t plus 1. You want at 2 seconds. So put t 2 seconds. So 12 plus 4 plus 1. 17 units. That is, radian per second. Now about the given problem. You have given flux linked to a coil. Flux given as 10 t square minus 50 t plus 250. So you want to find induced EMF at t equal to 3 seconds. So induced EMF is always equal to rate of change of flux with opposite sign. So whenever this is differentiated now, you get EMF. So differentiating this function with respect to t. So d phi by dt. So 10 into t square differentiation 2t na minus 50 into differential value of t 1 na. Next any constant 0, right? So you get minus, this is with minus sign na, so minus 20t plus 50. You want at 3 seconds, so put t 3 seconds. So it is minus 20 into 3, 16 plus 50, nothing but minus 10 volt. Units of EMF volt na. So flux differentiating with respect to time, you get EMF. So this is the formula we are using. Now the displacement of a body you have given, they are asking us to find velocity after 2 seconds. So whenever you differentiate displacement na with respect to time, you get velocity. So differentiating displacement with respect to time. 4 into differential value of t 1 na minus t square 2t, right, plus 3 into t cube 3t square na minus 4t cube. Okay, so you want to find at t equal to 2 seconds, right? So 4 minus 10 into 2 na plus 9 into 2 square minus 4 into 2 cube. Okay, so 4 minus 20, okay, 36, 32. Now, so 36 minus 32, plus 4, 8 minus 20. So nothing but minus 12. No, units meter per second. Now, the given problem is momentum of a body is given as alpha plus beta t square. Okay, so you want to find a force. So remember, whenever you differentiate momentum with respect to time, you get force, means dp by dt. Okay, so whenever you are differentiating this equation, okay, with respect to time, so dp by dt is equal to differential value of constant 0 plus beta into 2t. Okay, so this is the force on the body, nothing but 2 beta t. Now, momentum of a body in x direction and y directions you have given, so you want to find force. So, momentum of the body in x direction given as 2t square plus 6. Okay, so whenever you differentiate with respect to time, you get force in x direction. Okay, so 2 into differential value of t square 2t plus constant 0. So force along x direction 4t. You want after 2 seconds so substitute. Okay, so this is in x direction. Similarly, you can find in y direction also that is momentum given as 3t square by 2 plus 3. Okay, so when you differentiate this equation with respect to time, you get force, right? So 3 by 2 into t square differential value 2t, right? Plus constant 0. Okay, 2 cancel 3t. You are finding force after 2 seconds now. So 3 into 2, 6 units. So force along x direction plus along y direction. So it is 8 units, the other one 6 units. Therefore, the magnitude of force will become 8 square plus 6 square. So 10 units. Okay. Now, potential function you have given, we want to find electric field. Okay, so electric field strength is equal to minus dV by dr. Okay, so potential differentiated with respect to r, you get electric field strength. So potential function we have given. So whenever you are differentiating partially with respect to x you get Ex. Okay, dou v by dou x. Okay, so this is the given function So minus of, okay, so minus x square differentiation, 2x and y taken as it is, just like constant, because you are differentiating partially with respect to x, right? So minus x z square, okay, plus constant 0, right? So it is nothing but you can say 2xy, okay, plus z square. So this is about Ex. Similarly, we can find Ey also. Minus dou v by dou y partially with respect to y. Okay, minus of, right? So minus x square as is na differential value of y 1, right? Minus 0 because you are differentiating with respect to y na, so that is why the other treated as constants. Okay. Next, dou v by dou y completed. Now dou v by dou z minus of. Now you are differentiating partially with respect to z now. So this part is 0, right? Minus x into z square differentiation 2z now plus constant 0, right? So you get minus of minus plus 2x z. Okay, therefore electric field strength E becomes, right? You get Ex means 2xy plus z square na into I plus second one x square into j, last one 2xz into k. Okay, so this is the strength of electric field. Okay, now based on integration also we'll do some problems. So whenever momentum is differentiated with respect to time, you get force, right? So change of momentum is also called impulse, right? So dp is equal to f dt. So whenever you integrate on both the sides, you get impulse. So integral form of impulse is integral f dt. So you want to find impulse for first 4 seconds. Okay, so limits taken 0 to 4. F, according to problem, it is 10 plus 2t, right? dt. Okay, so it is 10 dt plus 2t dt. Between the limits 0 to 4. Okay? So 10 dt integral t between the limits 0 to 4 plus 2 integral value of t. So whenever x power n dx, you are taking x power n dx integral value x to the power of n plus 1 by n plus 1 na. So here power is 1, right? So you get 1 plus 1, 2 by 2. Between the limits 0 to 4. 2 to cancelled. Okay? Always upper limit minus lower limit na. 4 minus 0, right? Plus 4 square, no, minus 0. So 40 plus 16, 56. Okay, force into time na, so Newton second. Now about the given problem. So dv by dt, rate of change of velocity, okay, is given as minus 2.5 root v. Okay, so they said in the beginning the particle is moving with 6.25 meter per second and decelerated. Okay, so you want to know the time taken by the particle to decelerate. Okay, so if you bring all variables one side, okay, dv by root v equal to minus 2.5 dt na, so integrate, okay, between the limits 6.25 to 0, because you said the particle in the beginning is moving with 6.25 meters per second and decelerated, no, so 0 velocity. Okay, now about integration of dv by root v, so you can also take this to numerator na, between the limits 6.25 to 0, okay, so minus 2.5 dt is t na. Next, so integral part of minus half, you know, whenever it is x power n na, you are writing x power n plus 1 by n plus 1. Here n is taken as minus half na, so minus half plus 1 by, you know, minus half plus 1. Okay, half by half, nothing but, you know, 2 root v, right? So 2 root v na, limits 6.25 to 0, right? Minus 2.5 t. Okay, so you can take first upper limit, then lower limit, right? So you know, after simplifying, that is, you know, 2 into minus of 6.25 na, root, minus minus cancel now, into t. Okay, so when you further simplify na, cancel, you get t equal to 2 seconds. Okay, a graph is plotted taking time along x-axis, okay, velocity along y-axis. So you want to find the position of the particle, nothing but you can say displacement. After how many seconds? 5 seconds. Okay, so you know, area of velocity versus time graph gives displacement, nothing but you can say position of particle, but you want up to 5 seconds only, so you need not consider the total area up to 8 seconds. No, you want its position only after 5 seconds. Okay, so this shaded portion is only we require, right? So first one is a triangle now, and moreover all are on positive side, so they must be added now. So triangle, half base into height, base to height is also 2, okay, plus 2 to 4, difference 2 now, this is also 2, nothing but you can say it is a square, no, plus 4 to 5, 1 now, difference 3, okay, so cancel now, 2 plus 4 plus 3, 9 units, nothing but you can say 9 meters, means its displacement after 5 seconds becomes 9 meters. Okay. Now about the given problem. So there is 1 kg mass body. Okay. So there is 1 kg mass body. On it some force is acting. So that force is changing with respect to time. Okay. So you want to know work done in first 1 second. Okay. So you know work done is always equal to change in kinetic energy. So kinetic energy you can also find through momentum. No? So kinetic energy is equal to P square by 2m now. So change of kinetic energy is equal to change of momentum square by 2m. That means it's very clear that if you know momentum followed by it, you can find energy and you can find work done. Right? Now, so force is equal to 6t, right? So differentiating momentum, you get force, right? Or dp is equal to 60 dt, right? Integrate it on both the sides. Then change of momentum, right, is equal to 60 dt. So you want to find the work done from 0 to 1 second. No? So limits are 0 to 1. Okay? So integral t, t square by 2 na, limits 0 to 1, right? 2 divides 6 3 times, right? So momentum is equal to, okay, 1 square minus 0 square. So 3 kg meter per second. No, so that is momentum. So it is nothing but change of momentum. So change of kinetic energy also you can find now. That is kinetic energy is equal to P square by 2m. No, so 3 whole square by 2 into mass of the body. Here mass of the body is 1 kg now. So that is why 9 by 2. Nothing but 4.5 joule. So work done is equal to change in kinetic energy now. So work done during first second is 4.5 joule. Okay. Now in this problem, force function you have given, that is 2xi, okay, plus 2j plus 3z square. Okay, so you want to find work done between these 2 points. So small work done is force into displacement, or you can take work done as F dot dr. No? So F bar into dr means you can write dxi plus dyj plus dzk, right? So when you are integrating it on both the sides now, you get total work done. So 2x dx dot product a1 a2 plus b1 b2 plus c1 c2. No? So that is why integral, okay, 2x dx limits, x is moving from 1 to 3. No? So lower limit 1, upper limit 3. Okay? Plus second one, 2dy. Y limits, 2 to 6. Plus next one 3z square now, so integral 3z square dz. Okay, limits 3 to 1. Okay, so this is equal to 2 into integral x dx, x square by 2 now, limits 1 to 3. Okay, plus 2 as it is, integral dy is y now, between the limits 2 to 6, plus 3 now z square, integral value z cube by 3 now, between the limits 3 to 1. Okay, 3 cancelled, here 2 cancelled. Okay. So we can find work done. So integral dW is W na. So W is equal to, okay, 3 square minus 1 square. You know, always upper limit minus lower limit, plus 2 of upper minus lower. So 6 minus 2, plus, you know, Z cube, right? So 1 cube minus 3 cube. Okay? So you know, 9 minus 1, 8, plus 4 into 2, 8, right? Plus 1 minus 27. No, 16 plus 1, 17. 17 minus 27, you know, minus 10 units is work done. Okay? Now in this problem, there is one rubber band of length L. So work done in stretching. So you know, when you apply some force on it, it will deform. Due to its restoring force, you know, it will get back to its original position. So you can say the internal energy must be equal to work done. No? So work done is equal to, you know, force into displacement. No? So when you are integrating now between 0 to L, you get total work done, which is equal to, you can say, energy, right? So yeah, it is AX plus BX square, right, into dx between the limits 0 to L, right? So while integrating, you know, always the constants will take out of integration. Power 1 dx, right, between the limits 0 to L, plus b of x square dx na between the limits 0 to L. So a of x integration value, you know, x square by 2 between the limits 0 to L, plus b x square integration, you know, x cube by 3 na between the limits 0 to L. Okay, therefore when you substitute na upper minus lower, you get total work done. No? So therefore total work done is equal to, right, a by 2 of upper limit minus lower limit na, so only L square, right, plus b by 3 of L cube. Okay, so this is the work done. Now about the given problem. Okay, force taken along y-axis and time taken along x-axis. Okay, so a graph is plotted between force and time. So you want to find change in momentum. Okay, so you know, momentum is a vector quantity. So you know, the area of this product, force into time, gives, you know, change in momentum, or it is also called impulse. No, great force is acted within short interval of time. So it is very clear that area of this graph is equivalent to impulse. By taking the areas, you know, which are on negative side must be subtracted. That is, if it is a vector quantity. Otherwise you have to add all areas. So you know, change in momentum or impulse is a vector quantity. So that is why this area must be subtracted. This is added because you know it is on positive side of x-axis. Okay, so it is length to breadth to, no, square form, minus 2 into 2, right, area of this. So you know, this is equivalent to area now. So remember, area of force versus time graph gives impulse. Okay, so 2 into 2 minus plus. Why plus? Because it is on positive side. 2 to 6 now, so difference is 4, right, into 1, No? So plus 4 minus 4 cancelled, 0. Therefore impulse is 0. Okay? A graph is plotted taking time along x-axis, okay, velocity along y-axis. So you want to find the position of the particle, nothing but you can say displacement. After how many seconds? 5 seconds. Okay, so you know area of velocity versus time graph gives displacement, nothing but you can say position of particle, but you want up to 5 seconds only, so you need not consider the total area up to 8 seconds. No, you want its position only after 5 seconds. Okay, so this shaded portion is only we require, right? So first one is a triangle now, and moreover all are on positive side, so they must be added. No, so triangle half base into height, base to height is also 2, okay, plus 2 to 4 difference 2 now, this is also 2, nothing but you can say it is a square. No, plus 4 to 5 1 now, difference 3, okay, so cancel now, 2 plus 4 plus 3, 9 units, nothing but you can say 9 meters, means its displacement after 5 seconds becomes 9 meters. Okay. Now based on this cross product also you will be given definitely one question. Okay. So how to find cross product of two vectors? See, when you are taking two vectors, okay, so the two vectors are containing on this plane, so the resultant is moving in upward direction like this. Suppose you are taking the cross product of two vectors, the resultant is in upward direction. Okay, so in physics we solve many problems based on cross product also. So in this problem you have given about force and also position vector. You want to find torque. Okay, so you know torque is a cross product of position vector and force. Okay, so cross product will always gives us a vector quantity. Now we are going to know how to find cross product of two vectors. Very simple. You draw one box. First row you write I, J, K. So you want to find R cross F now. First you take R. So 3I plus 2J. So I quotient 3 now, 2J 2. No K term no. So take 0. Okay. Next F. I quotient 2 minus 3. There is no K term, that is why it is 0. No, I off. So whenever you are going to find I quotient, you close I column. Okay, J quotient, close J column. K quotient, close K column. So first I quotient you have to find now, close I. Right minus left. Anyhow 0 now. Minus J off, you know, right minus left 0, okay, plus K off, K, no, right minus left, minus 3 na, minus 4, always right side product minus left side product, so nothing but you know minus 13K. Okay. Now in this problem, the adjacent sides of parallelogram you have given, you want to find its area. So you know, area of parallelogram is equal to mod of A bar cross B bar, means the cross product of adjacent sides. So So here you have given P and Q now. So take P bar and Q bar. Okay. You know how to find cross product. Right. In the first row you write I, J, K. Next first vector. Now 3, 4. K term 0. Right. Next minus 5. Okay. 7. K term 0. Right. So first you have to find I quotient now. So whenever you want to find I, close I column. Right minus left 0. J always taken negative, remember. Okay. Again right minus left 0 plus K off. So K you are considering now. So close K column 21. Okay. Minus 20. Minus of minus plus 20 now. So you get 41K. Its magnitude you want to find, right? Mod. So root 41 whole square, nothing but you can say 41 square units. Okay? Now about the given problem. There is one alpha particle. Okay? So this alpha particle is held in a magnetic field. Alpha means charge particle now held in magnetic field. So it will experience some force. No? So whenever you place a charge particle in the magnetic field, it will experience a force, that is F equal to Q of V bar cross B bar. No? So this is the force. Alpha particle having 2 units charge, 4 units mass now. So V bar cross B bar. Charge of alpha particle. 2 units charge. No? So 2 into charge on electron 1.6 into 10 power minus 19 coulomb. Right? Now this cross product. So how to find the cross product of 2 vectors. No? I, J, K. Right? First you are taking V. Right? So 5 into 10 power 5. That is I quotient now. Cross B. So 3, 2, 0. Right? So how to find cross product. When you are taking I, I column must be closed. 0. Right? Minus J of 0 plus K of 10 into 10 power 5 now. That is about K. So you can write 10 into 10 power 5. Okay? In K direction. Okay. So 3.2. Okay. So 10 power 6 na. Units of force. Newton. Okay, so this is the force gained by alpha particle when held in the magnetic field. Now we are going to know about dot product of 2 vectors. So dot product is also called scalar product, right? So based on this dot product also you have given number of problems. So remember, one important point under dot and cross is dot. By doing dot you get the area that covered between the 2 vectors you get. By doing cross you get the total volume you get. Okay, so cross is a vector 1, dot is a scalar 1. So that is why it is also called scalar product. So in physics we come across different dot products. Dot product of force and displacement gives work done. Power, force dot velocity also gives power, scalar quantity. Next, electrical flux or magnetic flux. Electrical flux is E bar dot A bar, where A is area of cross section, not area. So remember, area is scalar, area of cross section is vector. So E bar dot A bar, or else you can take B bar dot A bar. Okay, so these are all dot products. Now based on dot also we'll solve now one problem. Okay, so in this problem you have given strength of electric field vector. Okay, so area is 100 units given in xy plane. Now, so xy plane now, so its projection taken along k. So 10 units in k direction is area of cross section. Okay, so E given as 8I, okay, 4J plus 3K. Okay, it is strength of electric field and this is area. So you want to find electric flux. Now, so flux equal to E bar dot A bar. Okay, so it is in xy plane, that is why you have taken k. Suppose yz plane, x means I you should take. Okay, so E 8I, okay, plus 4J plus 3K dot 10 100 K. Okay, so how to find dot product? A1 A2, B1 B2, C1 C2. So here no I J terms now, so that is why the quotient is taken 0. So that is why A3 B3. So 300. So 300 units is flux. Okay, so in this way it is easy to solve all problems. So go through each and every problem given in this video. I hope you can easily face any competitive exam. So if you like this video, please subscribe, like and share. And in order to subscribe, so there will be one icon given at bottom. So if you press, you can subscribe my channel. Thank you for watching this video.